Hello, welcome back to the channel. So let's do one more example on such type of questions where you have to interpret a function and calculate the signed area under the curve by only using geometry in this case. So we'll start with solving this question in the same way as we did our previous questions. So if you have not watched our previous videos, I would highly suggest you to first watch those videos in order to get the full context of this video. So let's start by calculating the area under the curve of this function. So the function is y equals square root 16 minus x square, and I have to calculate the area under the curve, the signed area under the curve in this case. So we'll first, as always, start by sketching the graph of this function. So since I have this function, which I can denote by y equals square root 16 minus x square, and if I have to sketch the graph of this function, I'll first simplify this expression, the expression over here. So let's simplify it down. Let's square both of these sides. So if I square both sides, I'll get y square equals 16 minus x square. And this is only done to simplify my expression so that I can see if it resembles one of my familiar shapes or one of the familiar functions that I already know a sketch for. So now if I move the x square on the other side, I'll get x square plus y square, and 16 can be written as 4 square. And based on this equation, based on x square plus y square equals 4 square, I can easily interpret, based on my prior knowledge of mathematics, that it's the equation of a circle with radius 4. But there is also one more important thing that you have to take into consideration, that this equation over here is the equation of a circle with radius 4 centered at the origin, but our original function is y equals square root 16 minus x square, and I know that square root always gives me a positive value. So since this is a circle, but my original function is the square root of 16 minus x square, I'll only take the circle which lies above my x-axis such that all the y values I have for my curve are all positive. And I'll have to discard the values, the negative values of y in this case, because my square root function will never give me a negative value. So let's sketch the graph of this function. I'll explain it in more detail what I mean by discarding the values, discarding the negative values of y and only taking the positive values of y. So let's sketch this function first. Let's sketch this equation, which would be the equation of a circle centered at the origin with radius 4. So if I sketch this one, it would look like this, where this is my y-axis, this is my x-axis, and the sketch of this equation would look like this, where this is my 4, this is my negative 4, because this equation represents a circle centered at the origin with radius equal to 4. And now since our original function is y equals square root 16 minus x square, which will always give me positive values for y, so I'll have to discard this area, because based on this function I can never have these negative values of y. And I hope it makes sense now. So our final sketch of this function would look like just this, where I have discarded all the negative y values. And now the process is pretty simple, right? I just have to calculate the area under the curve of this function, which is this sketch, between the intervals x equals 0 to x equals 4, which is from this point to this point, which is also the area under the curve represented by this region, right? And since I can clearly see that it's a quarter circle, I know that the area of a full circle is pi r square. So if I have to calculate the area of a quarter circle, since it's 1/4 of the total circle, so the area would also be 1/4 of the total area of a circle. And this would be my final answer in this case. And if I have to calculate it precisely, since my radius is 4 in this case, my total area would be pi times 4 square divided by 4, which is 4 pi in this case. So this is my final answer in this case, and it is equal to integral 0 to 4 square root 16 minus x squared dx. So that's it for this video. The only tricky part was to understand this function and only take the positive y values and not considering the negative y values. And the rest of the calculations were pretty simple. You just had to sketch the graph of the function and then calculate the area under the curve with the given endpoints. So let's wrap up this video right now. Please follow the channel in order to get notified about the other videos that I'll be uploading. Stay tuned. Thank you so much for watching. Bye bye.